Peter Tse attended Dartmouth College from 1980 to 84, where he graduated in this department, physics, and he also had a double major in mathematics. In fact, his senior thesis advisor was my mentor here when I joined, Joe Harris. And Jay remembers Joe. Right. Anyways, wonderful man. He was actually Heisenberg's postdoc. So Peter studied philosophy of mind at the University of Konstanz in Germany in 1987. He received his PhD in cognitive psychology in 1998. He then did a postdoc at the Max Planck Institute for Biological Cybernetics in Tübingen, Germany, where Kepler went to school, until becoming a professor at Dartmouth in 2001. He was a Guggenheim Fellow in 2014, and the focus of Tse's work is psychophysics and cognitive neuroscience is in a mid and high level human vision. That's at least one of the things that he does. He does many different things. And in his 2013 book, The Neural Basis of Free Will, Tse focused on the question of mental causation, its relation to the big question of free will. So let's welcome Peter. Thank you.
Does it work? No.
Is it on?
I will see. Probably on.
It's just a little switch on top here.
Testing, 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 testing.
Voila, should work.
No, testing? Still, yes? Is it working now? All right, good.
Yeah.
Well, it's a pleasure to be here. Thank you for inviting me. Today I'm going to talk a bit about causation, especially mental causation. The question of interest in this conference is experience and its role in nature, and central to that would be whether experience can be causal in the universe. So I'll zoom in on that question of causation. All right, so let me begin with a kind of story. So imagine it's the year 150 AD, and some soldier gets hit in, let's say, the hand right here by an arrow, and suddenly that person's toothache goes away. Now, Galen would say, well, that must be a coincidence. Whereas the very same injury in, say, Han Dynasty China would have been taken to be not a coincidence because they had a conceptual preconception of causation as patterns triggering patterns. Whereas in the West, this cultural bias didn't exist, where the cultural bias was for a more mechanistic conception of causation. And I have to wonder, where do these pictures of the world come from, such as our picture of causation? And I think it's before the age of 5, really. I'll give you an example. So my father, who came from China, trained our minds as a sort of cultural scaffolding that we all had. And he would ask us questions like, okay, what's stronger, an oak tree or grass? And we would say, an oak tree. What breaks in a hurricane? Whoa. Okay, grass, you think about it. Okay, so, but I think that cultures really differ in the kind of scaffolding they provide, the degree to which they provide scaffolding, and the picture they portray of the world. And central to the Asian conception of causation is global patterns triggering global patterns, which is mostly missing in the West. At best, it's been a minor theme. All right, so my own work focuses on the brain since I left physics, and lots to say about it. I'm going to zoom in on the question of causation in the brain. At the end of my talk, if there's time, I'd like to talk about the neural bases of experience and consciousness, if there's time, and address certain things people said yesterday. But I'm going to zoom in on the question of mental causation or neuronal causation. All right, so if experience cannot be causal, well, then it doesn't really play any role in the universe of substance. It would be epiphenomenal. Now, certainly experience seems to be causal. I mean, I can ask you the sort of village idiot question. Okay, describe to me what you're experiencing right now. And you might say, well, I don't know, my nose itches and my lower back hurts. Okay, well, in what picture of the universe can your description of your conscious experience, which influences the motion of atoms in your jaw, not be causal of the paths of those atoms? So it would seem just, on the face of it, that consciousness plays, or experience plays, a causal role in the universe. The question is, how can that be? Given that experience or consciousness seems to be rooted in neuronal activity. So my hope today is to try to convey a picture of causation that allows for experience to be causal in the universe. And the main message, I'll give you the take-home message, and you might not understand it at first, but I'll try to unpack it. So mind is causal in the universe, but not as a force or a thing. Instead, it is causal as a filter that allows only those possible causal chains at the rootmost physical level that are also informational causal chains to become real. Okay, so that might sound very strange. I'll try to unpack that and then return to it later. Okay, so the picture I will present will be physicalist, indeterministic, non-reductionistic, or holistic. Okay, but the first thing we have to do, I think, is address this argument, the so-called exclusion argument, which for me personally was the most troubling thing I ever came across in philosophy, or the philosophy of mind. And the argument, I'll just unpack it for you. So this is Jaegwon Kim. I actually became so consumed with this argument that I had to hunt him down. And I finally went down to Brown and spent a whole day with him, and he's like, you need to relax. You know? And he was actually very modest. He said, yeah, because he said, I must be wrong. Even though I'm a physicalist, a reductionist, I can't account for the nature of redness in my worldview. So in some sense, I must be wrong. It's up to you guys to figure out how I'm wrong. Okay, so here, this is not how he presented it, but I'll present his exclusion argument as a syllogism. Okay, so the major premise is all physical events are caused by preceding sufficient physical causes. In other words, all microphysical states are completely and sufficiently caused by antecedent microphysical states. Minor premise. Mental events are realized in physical events. In other words, mental events are realized in and determined by underlying microphysical states. Conclusion, the physical events that realize mental events have preceding sufficient physical causes. In other words, mental events are not causal even if they appear to be, because particle-on-particle causation or string-on-string causation or whatever is at the bottommost level is a sufficient account of how events unfold. There is no causal work left for mental events as such to do. All causation boils down to particle-on-particle causation, which is a level where mental and moral descriptions simply don't apply. Now, if this argument is correct, the exclusion argument excludes non-illusory causation of genetics, speech, baseball games, laws. It's all epiphenomenal. Everything, as Ned Block says, seeps down to causation at the level of strings. So, you know, I found this incredibly disturbing, and I thought, well, why do I even bother with neuroscience or neural coding? It's just all pointless. We should just be thinking about causation at the level of strings. And so I really struggled to find a way out of this. And I won't get into the details of it, but basically I believe that the exclusion argument does hold if determinism is the case. But his argument breaks down if indeterminism is the case. The main reason is that his key claim is this: if event E has a sufficient cause at time 1, no event at time 1 distinct from that cause can be a cause of E. Under determinism, this microphysical state is a sufficient cause of the next microphysical state. Under indeterminism, it's not sufficient, because this one might happen, but this one might not happen, that one might happen, or that one might happen, right? So it's not sufficient. The whole thing breaks down because of that sufficiency argument. Okay, but let's say indeterminism is the case. That's not enough to explain mental causation, right? So our challenge is to develop a believable physicalist account of downward mental causation that doesn't violate the known laws of physics and does not involve spurious notions of self-causation. All right, so here's the plan. The question is, can information or mind be causal in a physicalist universe when that mind or information or consciousness is realized in physical events like neural activity? Okay, so I'm going to ask, what is causation? What is biological causation? What is neural causation? And then look at the neural code. So what is causation? Well, it's a concept. It's a concept that has evolved over time. It's a cultural construct. Now, traditionally, people think of causality as schematized as event A at time 1 makes event B at later time 2 happen. Not only must A precede B, B must not happen if A does not happen. Now, so in the 1700s, the bias was to think of causation as something like energy transfer. And I'd say this is implicit in Laplace, Newton, the sort of billiard ball picture of causation. Now, in the 1800s, though, people began to think of causation involving not just energy transfer, not causation as impact, but energy transformation. And so all these people in chemistry really led to a change in the way of thinking. So you could take, sodium ions, chloride ions, and suddenly transform it into something that seems to have very different properties than either of those ions. Okay, and then later in the 1800s came along thermodynamics, where people started to think of causation now in terms of probabilities and things that bias probabilities. And I won't get into that too much. And then along in the 1900s, quantum mechanics. And there's people who are much more expert in that than me. So you have people like Heisenberg, Planck, Dirac, Einstein, Bohr, and Schrödinger came up with this very different view of reality. And there's a big argument about whether what the Schrödinger equation describes is epistemological or ontological. Okay, so we all know this stuff. Here's just one example to show how weird quantum mechanics is. This is the Aharonov-Bohm effect. So in that little circle behind the double slit, you can isolate a magnetic flux as much as you want. It can be infinitely isolated. And nonetheless, the degree to which you pass flux through there will change the diffraction pattern. It'll shift up and down, even though, in principle, no particle could ever pass through that magnetic flux. And so, Feynman's picture of this is that it creates a circuit of possible paths, and the flux through this circuit of possible paths creates a sort of current or something through. It's just madness, right? What does it mean to create a circuit of possible paths? Do they interfere with each other? It's very, very alien to our everyday conception of causation. Okay. Now, I would say physicists are thinking about this stuff much more deeply than biologists, or I would say even philosophers. Most of the determinists I meet are either philosophers or biologists or psychologists, right? And so this is the sort of state-of-the-art notion of causation coming out of the social sciences right now. This is Judea Pearl and James Woodward. He's at Caltech. They basically describe this as very linear conception of causation, the interventionist concept of causation, where you hold all variables constant, right? You shield them off or screen them off. You vary one, and then you look at its effect, right? That's kind of what scientists try to do, right? So they're kind of just describing what scientists try to do. I'd say this is a very, very incomplete notion of causation. First of all, causation is very nonlinear. And second of all, causation doesn't only involve manipulating inputs. It also involves manipulating responses to inputs. Okay. All right, so this A triggers B conception of causation that comes out of Newton is still kind of implicit in here, right? So under Newton, right? So this billiard ball triggers, if it with a certain impact, momentum, mass, and so forth, this billiard ball will trigger A, will trigger B to do this. Now, but imagine a different world where this B is not passive. B now can set criteria or conditions upon its input and say, okay, if it's a striped ball, I'll do that. But if it's a solid ball, I'll do that. And if it's an 8-ball, I'll do that, whatever, So that would be a very nonlinear, non-Newtonian notion of, well, playing billiards. But I would argue that this reparameterization of B's criteria for what it will do given its inputs is central to what evolved in the brain and therefore is central to experience. Okay, all right. So here's an example from the movies, right? So whoever built this tomb set some criteria for what would count as an intruder. And then, some traps, arrows or shot. But those criteria for what would count as an intruder, they might not be met for hundreds or thousands or tens of thousands of years. And then suddenly, Indiana Jones comes in, meets those criteria, and boom, the booby trap is released. Here's another real-world example of the reparameterization of the criteria for the release of some effect. Okay, so the Mossad had this problem. They had this bomb maker, I forget his name, Yusuf something or other. Anyway, this guy was killing all kinds of Israelis. And they needed to kill this guy. They couldn't, he was very well hidden. So what they did is they came up with a plan. They set up a booby-trapped telephone such that if a certain telephone number, which was the number of his uncle, I think in Paris, was dialed, it would blow up. So they fed these phones into the bottom level of the PLO. And it got tested hundreds of thousands of times. They were like, oh, it's just a safe phone, got passed up, until it reached him and it blew his head off. So this kind of booby trapping is very central to what neurons do. Neurons are kind of like little mousetraps. They're looking for the conditions in their inputs that will release their effects, namely causing them to fire. Okay, so we need to amend this sort of interventionist Pearl Woodward account of causation by emphasizing that the parameters whereby B criterially assesses A, namely its inputs, can be manipulated with no time constraints placed on when criteria may be satisfied. It might be thousands of years. So this traditional notion of causation, say John Stuart Mill here, a necessary characteristic of causal relations is temporal covariation of cause and effects. Okay, that seems reasonable given our current world picture. You do that, well, that has to follow right after, or it's some fixed delay after. Well, that alone isn't enough because, I could have a covariation between a rooster crowing and the sun rising. Well, that's consistent, but that doesn't mean that the rooster causes the sun to rise. And I know that because I can manipulate the rooster like that, and then the sun still rises. But Mill's covariation applies to traditional notions of causation, but not to criterial causation because the timing of the arrival of driving inputs is unspecifiable. So it's a really different notion of causation. Okay, and so imagine if I could reparameterize those releasing conditions for what counts as an intruder, and then go in. Then I could steal it. Okay, so we need to change our picture of causation. I think our picture of causation has evolved over time. It's a cultural construction, and it's evolving still. Okay, so let's look at what biology came up with. Now, what biology came up with was not rational. It kind of evolved because it stuck around. It worked. Okay, well, I would argue it's very unlike the Newtonian picture. So in biological systems, B has some say in the matter of A's effects on B because B places conditions on A for the release of some effect. How is this conditionality physically realized? An assessment of phase relationships among inputs. For example, shape and timing become central. Phase. So in physics, I started out in physics. You're going to learn a lot about amplitude of energy. You learn a lot about frequency of energy. There's much less emphasis on phase. Now, phase, it's given a nod, but it's not the central thing in causation, okay? Now, think about phase. It's the relationship between two things, in this case, two sine waves. It can be 90 degrees out of phase. A single sine wave does not have a phase. It's relative to something else that it has a phase. So by its very nature, phase is global in either space or time. It's about pattern. Okay, so evolution, I would argue, brought phase to the heart of causation in a way that didn't really exist in nature in a central way before. It really expanded on this. Here's just an example. Here's an NMDA receptor, and it sets conditions on its input. In this case, it's spatial. It says, well, if glutamate binds, and glycine binds, and if the postsynaptic neuron is also depolarized, only then will I open, right? But let's just take glutamate. Glutamate has a certain shape. Binds. That shape doesn't exist at one location. It exists in an extended way. Only then will this thing open up. Okay, so phase, in this case, spatial phase, or global pattern becomes causal in the universe. Now, I would argue that timing is another form of phase. Neurons are very sensitive to timing, to the timing of spikes or action potentials arriving. And at the global level of organisms, it's all about phase, right? I could listen to a single, it's global. I could listen to a single neuron in the, I don't know, some part of the, what is that? A lamprey. And I would hear the neuron go, psh, psh, psh. But I won't understand swimming in a lamprey, which undulates like this, unless I understand the whole circuit, which is this, in the right sequence. Otherwise, it would, if it didn't go in the right sequence, it wouldn't undulate, it would flop around epileptically. Right, so phase is central at every level, from the molecular to the cellular to the organismic. Okay, so the fact that there are detectors of phase relationships at every level, or pattern detectors at every level, gives rise to interesting metamers. Now, You've probably heard of the hallucinogens. The hallucinogens all bind to the 5-HT2A receptor and are essentially agonists of serotonin. And they all happen to have this little part that matches that little shape detector. And it doesn't matter what the rest of the molecule looks like. As far as that neuron is concerned, the criteria are met, that opens, and you have this massive opening of those receptors, which leads to all kinds of weird experiences, which you may have experienced. Okay. I would argue that this kind of phase detection is central at every level. We end up wiring circuits and neurons together that pick up certain patterns. So I could take a pattern like Orion, and because I was born in a culture that says that Orion is a thing, I don't want to count that as a thing, I will learn that pattern, and then I will have a neuron or neurons that respond to those conditions being met. Now, I could make that same pattern out of teddy bears or limes, and still those conditions would be met. So this is an idea, I think, that really was first thought of by Wittgenstein and brought into psychology by Eleanor Rosch. And so even though, I mean, Wittgenstein didn't think about neurons or the neural code, he had this insight that equivalence classes are defined by a set of criteria. Like, what are all things that, I don't know, whatever. What makes someone look Middle Eastern, right? You might say, well, they have dark skin. Well, that one has light skin. Well, they all have dark hair. Well, that one is blonde. Well, they all have aquiline noses. Well, that one has a stubby nose, and so forth. So what you end up with is some sort of set of criteria, like, let's say it's 10 criteria. And to be a member of that class of looking Middle Eastern, 5 have to be it. It could be this 5, could be those 5, could be those 5. And what you end up with is a family, resemblance as a family, a set of an equivalence class of things that look Middle Eastern, but they meet different criteria. So it's very fuzzy, but this is what neurons are doing. Okay, so I want to argue that biology introduced a new kind of physical causation into nature. Spatiotemporal patterns in input can be causal only if there are physical detectors, such as neurons, that respond to patterns in input and then change the physical system in which they reside if the criteria for the presence of a pattern in inputs have been met. So here's a very typical pattern for neurons: synchrony. So because neurons are leaky integrators, they have an integration window. Most pyramidal cells, it's about 25 milliseconds. Let's say 5 spikes have to arrive within 25 milliseconds. If not, you decay back to baseline, and it is as if that spike never happened. There's no history. So these things become pattern detectors, in this case, simultaneity detectors or coincidence detectors. Well, once you have a way to detect a pattern at this level, you can encode any other pattern in that pattern detector, like the pattern of Orion, or your mother's face, or whatever. Here's another pattern that's common among neurons: bursting. Okay, so this is a pattern triggering a pattern. It's not about mass and amplitude of energy or momentum or any of that triggering anything like Newton. It's really a really different notion of causation as patterns triggering patterns. Okay, the criteria physically realized in the response properties of the neuron are not about mass, momentum, heat, or any other aspect of the magnitude or type of energy. The physical neuronal criteria are conditions set on spatiotemporal relationships among some portion of the neuron's physical inputs, realizing informational criteria that are placed on the informational content present in neuronal input. Relationships among portions of matter that release an action by meeting some decoder's criteria are not themselves material and may only exist by virtue of the fact that the decoder responds to them. Only by virtue of having a detector that can read this pattern in input is this pattern potentially causal, as, for example, when that detector then changes the criteria for firing on other pattern-tuned detectors. So what's the difference with standard physical causation? Well, when water falls down a waterfall, it just happens passively. B places no conditions on A, so to speak. The water sets no criteria to be met by the rock, and the rock sets no criteria to be met by the water before some action is released. Causation here can be reduced to energy transfer among local particles. Global relationships among particles play no role in causal outcomes. In water falling down a rock, there's no decoder that waits for the arrival of a specific pattern of physical inputs before the water is allowed to fall or anything else happens. So information can lie in a global spatiotemporal configuration or pattern of particles, and importantly, such a pattern is not itself a local particle or reducible to particles. A pattern is not itself made of energy in addition to the particles in which it's realized. For example, a postsynaptic neuron may only fire if its presynaptic inputs arrive simultaneously. That simultaneity is a temporal relationship among particles. That simultaneity is a temporal relationship among particles, but that temporal pattern is not itself made up of particles in addition to the constituent particles that arrive simultaneously or not. Whereas energy or mass cannot be created or destroyed, information is itself not energy and has no mass. It can easily be created or destroyed. This is because information is not realized in the substance of energy per se, but its spatiotemporal organization. So here's another example. I was trying to explain this idea to my kids, and then they were like, what? I was like, okay, so I have a piece of Play-Doh here, and I can't change its amount, but I can make a little man. Oh, there's no more man. Oh, and then I can make a little house. No more house, right? There's no conservation of houses or shape or form or pattern. That's not conserved. Pattern follows a very different kind of physics, if you want to think about it that way, than amounts of energy. All right, so criterial causation is just pattern causation or phase causation, where global patterns of input trigger global patterns of output. Top-down criterial causation is rooted in reparameterization such that decoders now respond differently to input patterns. Okay, so now I want to move on to how neurons work. Neurons can not only make other neurons fire, they can reset the parameters for their future firing. This accomplishes the resetting of the informational criteria that must be met by future inputs to trigger firing. So when I talk to most of my neuroscience colleagues, I think partly because they grew up in this Western worldview picture, you know, they think of neurons triggering neurons like this, boom, boom, like a neutron at a billiard ball. So this action potential triggers that action potential, triggers that action potential, and that's not wrong. It's just incomplete. Because the neurons are not passive, they are evaluating their inputs, not the mass of the inputs, but the timing, the pattern of the inputs. And those criteria of the B neuron can be changed. Okay, so what we end up with is criterial causal change, where some conditions trigger one neuron, okay, which can trigger another neuron, and so forth. And it's, of course, it's not a black and white thing. It's a kind of like a dimmer switch. It can be, criteria can be met to certain degrees. But the point I want to make here is that neurons, inputs to the first neuron there on the left, if those criteria A, B, C, D are met, it can lead to the changing of the criteria on a different neuron. But that neuron doesn't have to fire. It's a different kind of causation than spikes triggering spikes. This is a big problem, because if the neural code is a synaptic reweighting code, we are measuring spikes. It's like we're looking for our keys where the light is good. So we have a big problem in neuroscience. Okay. So neurons keep their intracellular potential discrete because they each impose their own discrete set of criteria for firing on their inputs. If you had neurons with gap junctions, they would not be discrete and couldn't impose discrete criteria for firing. To enact discrete criteria for firing, it's necessary to keep the summation of potential in one cell separate from that in another cell. If the threshold for firing is met if and only if certain kinds of informational facts are true about the inputs, then the mechanism underlying neuronal firing assesses not only net potential at the axon hillock, it assesses these informational facts. In this way, physical criteria placed on physical inputs can realize informational criteria placed on informational inputs. Okay, so this leads to a new way to think about the neural code that emphasizes rapid synaptic reweighting as opposed to spikes triggering spikes. So I'm just going to give you an example of this. So if a monkey is told to attend to the left spot, you get a firing that is centered on the left spot. If the monkey is told to attend to the right spot, you get firing centered on the right spot. And if the monkey's not told to attend to either, you get firing sort of in the middle. Now, you're not going to change the inputs to that single neuron that they're measuring here by adding new axons to that. You can't grow axons that fast, right? The axons are set. So how is attention changing the responses of a single neuron such that if you attend there, it fires here. If you attend there, it fires more here. It has to be changes in synaptic weights such that you're changing the gain on this set of inputs and turning down the gain on those other ones, ignoring, or vice versa. So synaptic reweighting seems to be at the heart of the neural code, and it's fast. Okay, so it's almost like a yin-yang issue, where spikes are sort of like the yang, the active portion, and synaptic reweighting is sort of like the yin, the passive. You need both in order to have a neural code. Okay. Okay, so what are we up against? Well, this is a sort of standard picture of a brain's white matter tracks. This is sort of diffusion tensor imaging we do in my lab. Here's another picture that emerges out of this. The brain's sort of like a highway system, and we want to understand what connects with what. So you give Henry Markram €1 billion, or you give Sebastian Sung, 100 million, and boom, they're going to figure it all out. Well, maybe this is a bad metaphor. Maybe the brain isn't just like a highway system. I mean, maybe it is sort of, but let's say I only knew what the highways were that connected cities with cities in America. I would learn a lot, actually. I could say, well, there's got to be a lot of traffic between San Francisco and LA, but that's not going to tell me about traffic patterns, really, the timing of them. It's certainly going to tell me about the path of any individual car. Okay, well, here's a slightly better metaphor. Maybe it's more like the train track system. Okay, now in train tracks, you have these things. I think they're called shunts. I'm not sure what you call them. And they flip back and forth. And so the train could either go along that red track or that red track. So this very tiny little change has a huge effect on the path of the train. In effect, it sets up different epiconnectivities between cities. So I could, here's a map of the train system in America. I could take a section, let's take that section in Ohio, and I can connect. It can be part of, different connectivities between New York and San Francisco. In fact, that single train track could be part of a connection to Mexico or Toronto. It could be part of many epiconnectivities. So a single neuron can be part of many epicircuits. It's not that the information, then we get into a real problem, right? Because if information is not encoded at the level of single neurons, but at the level of circuits and epicircuits that are changing on the fly, and this neuron is taking part of this circuit, and now that circuit, we're going to have a real problem in figuring out the neural code because that's very global. So we have at least two problems in figuring out the neural code. Rapid synaptic reweighting, which we can't measure yet, and then the dynamics of global epicircuits. Okay, so I'm going to try to give you another metaphor to drive this idea home. So that the neural code is not just a spike code, it's also a synaptic reweighting code. In other words, information is not only transferred via action potentials, it's also transferred via synaptic reweighting. So this is a metaphor. Let's say, I need to pass energy through the system, but I also need to filter it. So let's say I only was able to measure your vocal cords, and I would measure them, and I would get, because the energy passing through the system is necessary but not sufficient for the communication to take place. But let's say I look at the filtering that's happening, which is the dynamic changing of my mouth. Now, if I measured only that, which would be analogous to rapid synaptic reweighting, I would get this. Again, necessary but not sufficient. You need the interaction between the energy passing through the system and the rapid filtering of that energy passing through the system, and then you get communication. Now, in neurons, the action potentials are playing the role of the vocal cords, and the rapid synaptic reweighting is playing the role of the changes of the shapes of your mouth. Okay, so you probably all heard, David Hume said, "'Tis impossible to admit of any medium betwixt chance and an absolute necessity." I think betwixt is a word that really should be brought back. Anyway, so this kind of notion of the neural code says, no, it's not. There is a middle way between utter randomness, over which you have no control, or utter determinism, which where things were set in stone before you were even born. And that is by the system placing constraints on what random events will count as criterial satisfaction. So let me give you an example. So agentically reparameterize the possibility space. This is realized in changing the physical informational criteria for neural firing via a neural code rooted in rapid synaptic weight resetting. So here, audience, think of a European woman. Okay, who do you think of? Okay, think of a European woman politician. Oh, that limited the space more. Okay, think of a European woman politician who has red hair. Okay, well, now I could actually limit the possibility so there's only one outcome. Think of a person named Peter C. So you might have come up with this one or that one, but why did you come up with that one versus that one, right? Well, it's not utterly random because it had to be a European woman politician who had red hair. But given those constraints, it could have turned out otherwise because there's more than one criterial satisfaction of those pretty narrow conditions. So this kind of causation is everywhere in our lives, right? So why did you marry that person, right? Well, presumably you have some criteria, but you married, say, her or him because you turned left that day rather than right, and you met them first, and they were above threshold. Now, don't tell this to your spouse, honey. You were above threshold first. But and it depends on where we set this threshold. But we have some set of criteria. Let's say you like men. Okay, so I don't know. Most people who like men want them to be kind and funny and handsome and intelligent and not a criminal and not have AIDS. Okay, all kinds of stuff. But why? Still, no matter what that set of criteria is, as long as it's not infinite, you're going to meet somebody who is above threshold, and that person will then perhaps become your partner, right? So you like women. Well, I like women, and so I married a woman, but I didn't marry a cloud or a tree or a goldfish, right? Because those would not have met my criteria. Okay, so yes, and we can play with the causation by playing with the threshold. Okay, so information is causal. Information only comes into existence by virtue of a decoder receiving input that matches its conditions, typically placed on the phase relationships or patterns in incoming energy for the release of some effect, say an action potential sent to other such decoders or neurons. But a decoder also serves as a filter on the set of all potential causal inputs, since it will only change the system of decoders in which it is embedded, namely by firing, if its physically realized informational criteria are met. Information is downwardly causal, not as a material force. Information is causal as constraints that only allow the realization of sets of possible physical causal chains at the rootmost level of strings or whatever that also comprise informational causal chains. Physical laws are not violated by this. Every possible physical causal chain conserves energy and momentum and so on. But only those possibilities allowed by physical laws, which also meet informational criteria, pass the physically realized informational filter and become informationally causal, either by reparametrizing the criteria by which other neurons will assess future input, by changing their synaptic weights, or by triggering other neural firing. So information is multiply realizable because which particular set of spike inputs, and thus what particular information will make the neuron fire, is unforeseeable, so long as the physical informational criteria for firing are met. If neural causal chains are also informational causal chains, and informationally equivalent informational causal chains are realizable in multiple different neural or particle causal chains, then the parsimonious model is one of information causing information. Yes, there must always be some physical realization of information, but under physical informational criterial causation, which one it happens to be is irrelevant so long as informational criteria are met. Chains of successive informational criterial satisfactions and criterial resettings afford the physical realization of downward mental causation. So whatever, let's say this neuron is, I should stop? Okay, okay. All right, so I know some people like the block universe picture of all actualities. It tends to be a deterministic picture, but you can also have a block universe now of all possibilities at the moment of the Big Bang or whatever the beginning was. And it's also like a kind of block, a block of everything that's possible. But what happens now is that we're able to sculpt out this chain of actual causation versus that one by setting certain kinds of criteria. And so in our lives, for example, we can sculpt out, we can say, I want to become a doctor, or I want to become a rock and roll star, or whatever. We can ourselves change the conditions that will lead to the sculpting out of this, among all possibilities, this causal chain becoming actualized versus that other one. All right, so let me conclude. Information can be downwardly causal because of criterial causation. Only physically possible outcomes which are also informational satisfactions of preset criteria can occur, can be realized, can become real. We have to rethink interventionist accounts of causation to include criterial resetting and nonlinear input-output relationships, and mind is not causal as a force, but as a filter on which possible paths can become real, and it's rooted in patterns. So all these ideas are in this book, which you can read. It's mostly a neuroscience book, but these are ideas that are in that book. And I'll just leave the take-home message there, and if there's room for questions, I'm happy to take them, or no. Yeah. Okay. Wait, but the next is coffee?
So yeah, questions. Okay. Anybody, one question? Maybe two?
Adina.
So I really like the picture, but I think that it is just as susceptible to Kim's exclusion argument as every other story. I mean, all of those things that you point to neurobiologically are themselves realized by physical mechanisms, receptor translocations or bindings, et cetera. And so the solution that you propose is essentially the same as Diablo's solution, which is that the way that basically exclusion isn't the right answer. You don't need, even if there is a low-level explanation of the phenomenon you're interested in, it's what you're interested in that dictates the right level of explanation. So if you're interested in informational or, let's say, mental phenomenon, then the right level of explanation is at a higher level than the physical explanation, and it's not excluded by the existence of a physical explanation. So I can point you to the...
Yeah, I have not heard of Diablo's paper, so I don't know what you mean by that. But
I think that that's the right way to approach the exclusion phenomenon, but it doesn't...
No, I just disagree. I think if the exclusion argument is correct, then all causation only happens at the rootmost level. It may appear, like I can make my shadows appear to hit each other, but I know that there's no causal efficacy at the level of shadows hitting shadows. If the exclusion argument is correct, it's all shadows all the way up. Genetics.
The exclusion argument is correct for precisely the kind of reason that you gave, but...
Well, I think the exclusion argument holds if determinism is the case, because in that case, the microphysical state at time 1 is a sufficient cause of the next stage, whatever, time 2. Only under indeterminism does it fail. But that's not a solution to how mind is causal in the universe. It just gives us wiggle room to create a story where mind is causal. Okay.
Yeah, I'm sorry,
No.
guys.
My fault.
We should have been done with the coffee break by now.
Okay, I don't want to stand between you and coffee.
So let's keep going.
All right, thank you.